Good morning, everybody. So far this meeting, we talk a lot of bits, bytes, packet, and a lot of policy. Generally, it's all focused on the software side, right? So next 20, 30 minutes, I'm gonna change the subject a little bit, touch base on the hardware. So specifically on the optics, router optics, switch optics, and hopefully can give a whole picture, kind of like a snapshot. So what is the landscape on the router side? So I'm a product line manager, so work on the router side. And why do we really care about optics on the router, right? So it's a part of like, it's a part of like a given, go with the router. And one thing, interesting thing we noticed for the last few years, we offer a solution to operator, to the end carrier. More and more cost actually go to the optics side. And so we need to really think about how do we actually offer a overall better solution from the cost CapEx perspective. And also, we have a more chance to see when we really need some specific optics on router, they're not available. And it's a technical challenge, or the timing is not matched. So here's a few topics I want to cover in the next 20, 30 minutes. So the router optics versus the transport optics. People kind of like easy to lump together from the optics perspective, right? So automatically lump them together with the transport, because they are important piece of the network equipment. A touch base on the router optics evolution. And then we maybe walk through few cases in the real field for 100 gig optics with router. What are the real practical issues? Then we touch base on what's next. So many people, my personal experience, right, when we start to talk about optics on the network equipment, automatically think about, hey, like we have a huge optical transport industry over there. A lot of investment go over there, right? So, but many of the transport system, most of the focus, most of the investment really focus on go WDM system, the CDC ROADM, long haul, ultra long haul. What are the best performance? What are the spectral efficiency? So they're kind of like orthogonal compared to, from the router perspective, what is the requirement for optics? So this is the picture, right? So the red part obviously is the transport gear, and the blue side are the routers. So from the router perspective, what are the major points we need to consider? It's density. We are looking for small form factor, lower power, lower cost. Right, so most of the applications, they're gray optics. Could be pluggable, could be fixed. They're not WDM. So from architecture perspective, the top one is a majority, vast majority of the architecture, right? So we have a router, either co-located within a short distance with a transport gear. So we use a gray optics, hand it over, and then convert it to WDM, the color interface. Some specific newer applications start to emerge, right? So mainly for metro, for ring structure, maybe point-to-point configuration. So we start to see a integrated DWDM directly on router. So newer architecture, but that's only part of the story, right? So that's data plane integration. And beyond that, we still need to do a lot of other work. And, but architecture, majority of them is the top one. So when we talk about the router optics, we actually have all different kind of router application. And each of them, they have a different requirement. So on the picture on the right side is the core router. It's really sensitive. We are really pushing for is very high density, very small form factor, lower power, thermal cooling. And then we move to the middle, to the edge router, and the requirements become different, right? So maybe balanced from like low data rate, 10 gig, 40 gig, 100 gig, versus for core router, start to push for 100 gig and even beyond. And then we go further on the wireless gateway router on access aggregation. So we might have a different requirement, right? Mainly focus on 10 gig. How do we save fiber, reach out a longer distance, reduce the cost? And when the router is getting closer and closer to the cell tower, we might need a requirement for an extended temperature. My city in the cabinet have a size limitation, have an airflow requirement, different directions. So I want to start focus on the 100 gig, right? So this is the year 100 gig mainly, right, become a mainstream. So we start from, let's say, beginning of this decade. Routers start to offer 100 gig interface. The very first one, pluggable, is a CFP. Every 2 years also move along, we come out a newer one. Reduce the size, maybe half the size, right? From CFP to CFP2, CFP4. It's kind of interesting. A couple of years ago, 2-3 years ago, there's a pretty big argument in the industry. So we move from CFP2. What's the next one? Should we bet on the CFP4? Should we bet on the QSFP28? Smaller form factor, lower power. This is really from the router perspective, right? So which one better fit? So clearly in the industry, QSFP28 had the majority of the market. Moving forward, we can see the beyond 100 gig, let's say 400 gig, 200 gig, right? Our multiple 100 gig is already on the horizon. So the first one, the 400 gig, the form factor is a CFP8. So CFP8 form factor is roughly the size of a CFP2, but obviously, right, so change the data rate from 100 gig to quadruple to 400 gig. But moving forward, I call the second generation 400 gig. What will be the form factor? A little bit deja vu, right? So in next year or two, we have a few choices, practical choice, right, in front of us. One is QSFP-DD, double density, and the other one is OSFP. So they both have advantage and disadvantage. So OSFP, the form factor is slightly bigger, like 22 millimeter width. And so from overall density perspective, from router side, it's on par, but a little bigger than the QSFP-DD. But they can host higher power. The QSFP-DD, on the other side, yes, we have a more technical challenge to fit everything into that double density module. But the advantage for that is we can actually start from today to develop a line card. This line card, we can host QSFP form factor. We can support QSFP28. We can backward support QSFP plus 40 gig, 4 by 10 gig. Moving forward, we can support 200 gig, 400 gig QSFP-DD. But for OSFP, it's a brand new development. So every single development on the router, a line card, costs millions of dollars, right? So something interesting will come for within next 12 months to 24 months. We'll see which one ended up will dominate the market. Then overall, we talk about the router optics. What are the challenges? So from the top level, we can see the major building block for a router hardware. One is the network processor, let's say the ASIC, right? Either a commercial off-the-shelf one or all the major router company, we have our in-house developed ASIC. So every few years, more like, I don't want to say exactly follow Moore's law, but kind of like follow that path. We increase the capacity, right? Increase the density. And so eventually we hit the point, the ASICs are already available. We can support a much bigger capacity, but the bottom picture just try to show we already use up all the front panel, just mechanical space. Optical module all have size, have power, right? So we can only fit so much. So this is one of the challenge. So ASIC development outpace optical module bandwidth. And we also constantly have this kind of challenge. Should we stay with the current, for example, this year, 100 gig module, or we should move to the next higher speed module? When you first jump into the higher speed module, obviously, you don't have the cost benefit. You have some other benefit, but it's extremely difficult to see, like the early days of 100 gig, right? So the baseline 100 gig module cost need to be absolutely smaller than 10 times 10 gig. But the early days, you cannot achieve that, right? The real goal is not just 10 times. It should be maybe 5 times, maybe 4 times, right? We can improve the cost. So same thing, moving forward from 100 gig to 400 gig. So physical size, power, and a router like, so I had a break time discussion yesterday. So a kind of like a router total power increased so dramatically for last 15, 20 years, right? So a one core router, right, with full service, we are talking about 20, even 30,000 watts. So many of them actually contributed by the optical module, right? With those kind of very big power box, how do we thermally manage them? Can we thermally manage them just for the optical module? And then we have some other, more like I call it a trailing problem, right? So it's not a cutting edge, but a lot of deployment over there. The edge router, aggregation router, access router. So maybe 10 gig, but we want to save fiber, right? The metro distance fiber, 80 kilometer, 40 kilometer. Can we squeeze more to the fiber? Let's say bi-directional, that's one way. And try to minimize the cost, not use WDM. Can we go a little longer distance, even beyond 80 kilometers? So there's many different kind of challenge. And another one is nowadays the router getting closer and closer to the cell tower, right? We have a internal kind of like survey. It's double-digit percentage of the smaller router actually need to sit in the field, maybe on the curb, maybe somewhere, outdoor in a cabinet. So we need extended temperature module. So all those things are top level why we're facing some challenge to offer a good solution on the optics side for router. Let's back to on the 100 gig side again. So this is also a kind of like, this is more like the whole landscape. Most of them are QSFP28. Yeah, we saw it maybe 10, 15 years ago for 10 gig. Have so many different flavors, right? But this is for me at least, right? So it's the first time ever for one optical form factor we have so many diversified, different kind of flavor. What are the reasons? So the major reason is linked to a solution cost. So mainly web-scale company and some big carriers, we are considering to push optimized design with different kind of performance, different kind of distance, obviously associated with different kind of cost. So instead of the traditional define LR, the 10 kilometer, the LR4, and the other end is SR, so some other things in the middle start to pop up. CWDM4 only support 2 kilometers with a lower cost, possibly lower power. PSM4, 500 meter. So many companies think about link the router, right? Spine, leaf, switch, and the data center router. 500 meters is a magic number. So this PSM4 can address that with lower cost. And we need a longer distance, beyond 10 kilometers. We need ultra long distance, one span. I don't want to co-locate with a transport gear, MUX, DMUX, converted to amplifier, WDM transponder. How do we address that distance? So this is a kind of like snapshot picture for the 100 gig QSFP28 and some of them CFP4. So let's quickly walk through some of the challenge in the field. So from the early generation CFP few years back, 2010, 2011, and then the second generation CFP2, all the short reach multimode fiber is 10 lane, 10 gig per lane. And now, when we move to higher density or smaller form factor, lower power, it's extremely difficult to integrate all those lasers, all those receivers into the smaller module. So now we use 25 gig lane, 25 gig NRZ, 4 laser, 4 receiver, right? So I have this one customer, big tier 1 customer. They want to know, how do we address that issue? Short reach is the way to go. I already have all the multimode fiber in the field, already connected. I really like the higher density, low cost new router. How can you help me to link them together? From 10 gig per lane, 25 gig per lane. One practical challenge. Maybe a niche market, but there's one challenge. We haven't even sorted out what is the best way to do it yet. But one option is some company working on a mechanical adapter, plug in one end on the CFP2, and the other end, you can just put on the QSFP28. But some other next level detail, the new QSFP28 SR, you need FEC. That also need to be addressed. So the second one is the ER distance. The IEEE defined standard 40 kilometer. The whole industry really worked hard from first generation CFP, move the second generation CFP2, we can support ER4. Unfortunately, for the new form factor, the CFP4, QSFP28, at least up to today, there's a technical challenge. Nobody can do it. Yeah, they tried all these different ways to increase the laser output power, swap the receiver with APD, still cannot do it. So industry quickly put together a non-standard, but I might say, right? So it's called a 4WDM. So the idea is we add FEC on the host board and to help to extend the distance. Without FEC on the host board, just this module, optical module alone, it can go 20 kilometer, maybe 25 kilometer-ish. That one can also interoperate with the in-the-field CFP2 or CFP ER4, but with a limited distance. If we need to go all the way to cover the 40 kilometer, there's a challenge. Even this idea, right? So the modules not exist. So we have been from the router, from switch company perspective, we keep pushing the industry, pushing the community on the transceiver side to develop that module for us. I believe it's coming within this year. So the other one is, yeah, it's further longer distance, like 80 kilometers. We start to offer, you can see in the industry, use a simplified design, coherent 100 gig, called a CFP-ZR, to address that 80 kilometers. But moving forward, that's a CFP form factor, right? So nowadays, the router interface already moved to QSP28, CFP4. How do we increase the density? So the new one, potentially, there's two options. One is already kind of like a coming at the door. It's a QSP28 ZR, but unfortunately, it's not coherent technology based. It's PAM4 technology based. The other one cannot interoperate with the existing one in the other end. The other option, potentially, CFP2 DCO, simplified design, can also address this issue. And the other one, I used to use a story to explain, right? So it's like the carrier, your facility is already in the field, right? It's extremely difficult to move your facility to shorten the distance. And so when we have more and more router move closer to the field, right, to the curb, to the cell tower, we already have the pressure. The optical module need to survive from negative 40 degrees to very high temperature. Again, this is another module, it's not exist for the whole industry. Nowadays in the field, the deployment, they are all 10 gig. And how do we come out something can address that issue? So allow the smaller 1RU, 2RU, smaller access aggregation, smaller router, and the backhaul router to increase the data read, especially the upper link, right, from 10 gig to 100 gig. That's another challenge. So I believe the module could be available later this year. I want to touch base a little bit on the 10 gig side, right? So even though industry is quickly moving to 100 gig, but still there's some requirement in the field based on 10 gig, right? How do we support a bidirectional beyond 40 kilometers, let's say 80 kilometers, 60 kilometers, or even beyond? We need some special optical design. How do we address more than 100 kilometer ultra long distance one span without a WDM system? So one thing we noticed in the last whatever years, right? Most of the network engineers, they want to focus on the packet side. They want to use the CLI to configure everything. So link the router, link the switch, instead of handing over to a transport, and then that's a different domain. So those are some of the challenge. And the other one is, even we quickly move the router switch interface to 100 gig, we still have a lot of 10 gig interface in the field. How do we support higher density, or the 100 gig equivalent density, 10 gig, to address the downlink linked with a lot of other smaller routers? Those are the challenges for 10 gig. Then we talk about the other way around. Moving forward, already some big companies start to request, when should we support beyond 100 gig, 200 gig, 400 gig, and beyond? Is there a market for router to support 100 gig density higher than QSFP28. QSFP28 is like the default, right? The best so far. So one way to think about, we bump up all the data lane to 100 gig. We can support SFP, let's say 112, smaller form factor. But that electrical interface, 100 gig electrical interface, gonna take a long time to mature. Maybe another 4 or 5 years, maybe even beyond. Then how do we address the issue? My next generation router, switch from the ASIC perspective, we can support much higher density. But from the interface perspective, QSFP28 is not enough to take advantage of the capacity for 100 gig. So another way is develop, like I call it N by 100 gig, 2 by 100 gig, 4 by 100 gig, different form factor. It's a little bit eye chart, right? So that's theoretically different kind of combination, what we can do for N by 100 gig. Now we need to touch base a little bit on the 400 gig. From the ASIC perspective, it's ready. It's ready a few years back. That's one of the typical story. When ASIC already can support a higher capacity, unfortunately, the optical industry, they are trailing. There's no 400 gig interface before. So this is the first year we're gonna see 400 gig pluggable module, CFP8, can be used. And next year, 2, as I briefly mentioned, right? So OSFP, QSFP-DD based 400 gig will come to the market. So there are benefits over there. Also challenge, right? Benefits mainly lie on, let's say, simplifying the fiber management on the router. Each 100 gig come out, fiber connected, right? When you have so many 100 gig, like the old days 10 gig, even the fiber management is a challenge. And the other one from packet perspective, right? We can ease the concern for the lag bundle because we quadruple the data read. But on the other side, the early 400 gig might not achieve the goal from the cost perspective, less than 10 times of 10 gig. This is the last topic I want to touch base before the closing. It's on the integrated DWDM. So the picture shows everything, right? For specific application, metro distance, point-to-point ring structure, we can simplify from the data plane integration from the top picture. You hand it over grid optics, think about 100 gig, more expensive, more 400 gig coming. To the bottom one, you move the color transponder directly on router. You remove, for this one simple point-to-point link, 4 expensive 100 gig module. You also simplify the optical node in the middle because you don't need a host transponder. You don't need a host pluggable module, right? And can be a optimized design for this application. Much simpler, maybe amplifier, filter, something. So it's the one way to think about it. On the other side, when we have the integrated WDM on router, we have from the packet layer, from the router perspective, we have the full visibility what's going on the transport side. We can easily provision the service. Again, right, CLI. Line up another path, 100 gig. We can also quickly reroute, trigger the FR, because we know what's going on the physical layer. So there are some benefit but also a lot of limitation, right? The transponder, the color transponder density is not as good as the gray optics, pluggable optics. So there's a density mismatch. And the product life cycle as a router typically is shorter. Let's say maybe roughly give or take, maybe half the life cycle of the transport gear. But nevertheless, for some special application, this is the one way to go. So let's briefly talk about what are the trends moving forward. Router optics. So 100 gig quickly become the new 10 gig. What I mean over here is 10 gig stay in the industry for a long time, 15, 20 years. 100 gig paved the way, right? Stay a long time. ASIC and optics really dictate the cost of router. It's a major network building block. Router is getting closer to the field, to the wireless equipment. So we need a smaller size, less power, maybe ANSI compliant, extended temperature. We used to call the client optics and line optics, right, the WDM, the line getting blurred. If you open up some 100 gig module, inside is CWDM with a filter. It's multiple wavelengths. And the last point over here is we can see in the next few years, the short reach, less than one span WDM are coming. Because the data center, right, so grows so fast. 100 gig, go higher density. You still want to squeeze in more channels into one fiber, maybe only 10 kilometer, 40 kilometer, let's say 80 kilometer, but you save fiber. That's the end of talk. I'm open for questions.
Hey, Lane Wigley, Cisco. Thanks for a great talk. Can you talk a bit more about your view on breakouts in 400 gig E?
Breakout on 400 gig, yeah. So there are few challenges over there, right? So one is when we break out, let's say use QSFP-DD as an example, right? So we can support the industry can support a breakout 4 by 100 gig, but that 100 gig, very possibly we need a 100 gig lane PAM4 based optics. It fit in with the QSFP form factor, but it's not the same as the current available QSFP28. So we need a new 100 gig module to interoperate with the other side when we break out.
Hi, Samuel. James Taylor with Bluebird Network. We've got legacy Alcatel-Lucent gear in our network, and I'm excited to hear about Nokia's plans. Are you guys moving forward? Are you integrating the ALU gear with legacy Nokia gear, or how are you doing that on your roadmap to 400 gig?
So Nokia have multiple divisions, right? So the router side actually comes from Alcatel-Lucent. So we're under the same roof, the same division, router side and the transport side. So we work very closely with my counterpart on the transport side to start to address what are the next one, the 400 gig. As I said, right? So from the time to market consideration, CFP8 is the first one, because that's the only available one this year. And we need to build up some solution, right, to support 400 gig end-to-end. But that's the plan. All right. Thank you very much.